Preeminent among the modern wave of maths popularizers was Martin Gardner, an American writer with a bachelor's degree in philosophy from the University of Chicago and a keen interest in maths puzzles, magic tricks, and the debunking of pseudoscience. His articles on recreational maths, which appeared monthly in the Mathematical Games column of Scientific American for about a quarter of a century, beginning in December 1956 with a piece called Flexagons, encouraged a generation of young people to enter the field and enthralled many others, from professional mathematicians to interested bystanders. Such was Gardner's stature that world-class specialists such as John Conway, Richard Guy, Donald Knuth, and Roger Penrose corresponded with him regularly and saw their work explained in an easy, enticing style to millions of readers who might otherwise have never heard of Conway's Game of Life and other cellular automata, polyominoes, the Soma cube, Penrose tilings, or the supraellipse. As Gamow had done earlier, Gardner adopted a fictional character, Dr. Matrix, to add spice, humour, and a little satire to some of his mathematical explanations. Dr. Irving Joshua Matrix was first introduced in Gardner's Scientific American column in January 1960 and went on to make 18 appearances in all, before taking his final bow in the September 1980 article titled Dr. Matrix, like Mr. Holmes, comes to an untimely and mysterious end. So much popular maths-related material, both factual and fictional, had built up even before the likes of Gardner got into their stride, that American editor, author, and earlier media personality Clifton Fadiman was encouraged to pull together an anthology of such writings in his Fantasia Mathematica, 1958. 40 years later, William Frucht, an editor with whom I've worked, composed a similar collection of mathematical articles, short stories, poems, and other whimsy. He called it Imaginary Numbers, and wrote it after failing on various occasions to persuade Gardner to take on the task. Popular maths literature, much of it injected with elements of humour and fantasy, began to mushroom in the late 1970s and early 1980s. American professor of cognitive science Douglas Hofstadter won a Pulitzer Prize for his Gödel-Escher-Bach, An Eternal Golden Braid, 1979, a book that explores common themes in the works of logician Kurt Gödel, artist Morris Escher, and composer Johann Sebastian Bach. In his July 1979 Mathematical Games column, Martin Gardner wrote of it, "Every few decades, an unknown author brings out a book of such depth, clarity, range, wit, beauty, and originality that it is recognized at once as a major literary event." Hofstadter employs an unlikely duo who were first called upon to explain some tricky concepts to the public 2,500 years earlier. Achilles and the Tortoise debuted as a double act in the writings of philosopher Zeno of Elea, famed for his paradoxes that bore upon the nature of infinity. The best known of these is illustrated by a handicap race between the swiftest runner of ancient Greece and the slowest moving of reptiles, which the tortoise argues, compellingly but wrongly, he's bound to win. Lewis Carroll recalled the pairing in What the Tortoise Said to Achilles, an article he contributed to the philosophical journal Mind in 1895. Again, the tortoise proves that, in mental agility at least, he's more than a match for his heroic opponent by outwitting him in a debate on logic that leads Achilles floundering in an infinite regress. Hofstadter reprises the combo, having them engage in numerous lengthy dialogues throughout Gödel-Escher-Bach. The two are joined by other characters, including the crab, the anteater, and the sloth, in chatting about and illustrating self-reference, formal rules in logic, how knowledge can be represented and stored, and the emergence of consciousness from unconscious matter. Gödel-Escher-Bach may rank among the most technically dense books on maths and logic ever written for a general audience. Most people will need to reread it and study it almost like a textbook to grasp properly what it's all about. But it succeeds even in explaining such esoterica as Gödel's incompleteness theorems, through the clever use of playful ideas and fanciful characters who speak plain everyday language. The success and popularity of authors like Gardner and Hofstadter encouraged other mathematicians to try their hand at writing about their subject in a whimsical way. It's an approach that works because it counterbalances the common perception, often gained in school, that maths is dry and difficult. Rudi Rucker taught mathematics for several years in the 1970s in the State University of New York at Geneseo, then lectured in Heidelberg in Virginia before spending the rest of his academic career until retirement as a professor of computer science at San Jose State University. Rucker was an early contributor to the cyberpunk movement and wrote prolifically about maths both in fiction and non-fiction for the layperson. In Pie in the Sky, a couple skin diving on their honeymoon come across an artifact from Barnard's star, lost on the seabed during the crash of an alien spacecraft. Cone-shaped and marked with countless black rings, it gives off an intricate pattern of hisses. The device turns out to be a kind of portable hard drive that holds all the knowledge of the Barnardians in a fantastic form coded in the decimal expansion of pi. The same idea found its way into the plot of another and much better known story a couple of years later. My notion of pi as a kind of universal library, remarked Rucker, reappears in Carl Sagan's novel Contact in 1985. Rucker also brought fanciful elements into his non-fiction, including the fourth dimension and infinity in the mind. In a similar vein, Clifford Pickover, Ian Stewart, Alex Bellos and others of the current crop of popular maths writers often use playful examples, invented characters, and fantastic settings to make accessible topics that might otherwise seem remote and hard to fathom. In recent years, the lives of several famous mathematicians have become better known through popular biographies that in some cases have been adapted as films. A Beautiful Mind, 1998, by Sylvia Nassar, recounts the troubled life of Nobel Prize-winning economist and mathematician John Forbes Nash, who battled schizophrenia. It inspired the 2001 Oscar-winning movie of the same name, directed by Ron Howard and starring Russell Crowe as the central character. Ramanujan too has made it onto the big screen in the 2015 drama The Man Who Knew Infinity, based on the 1991 book with the same title by Robert Kanigal. Rain Man 1988, likewise based on a true story, co-stars Dustin Hoffman as an autistic savant with a photographic memory and a genius for mental arithmetic. Goodwill Hunting 1997, written by Matt Damon and Ben Affleck and starring Robin Williams, is about a young man who's led a troubled life but has an amazing talent for maths. His abilities are discovered when he falls foul of the law, and soon after he has to decide whether to focus on making the most of his mathematical genius or carrying on with his old lifestyle. In Darren Aronofsky's disturbing independent film Pi 1998, the main character is a mathematician obsessed with searching for patterns in pi's infinite decimal places. He believes these patterns could be used to predict chaotic behaviors, including that of the stock market. Throughout the story, he's pursued by ruthless financial players and by religious zealots hoping to find a mathematical way to communicate with God. Maths has also found its way onto the stage. The musical Fermat's Last Tango 2000, performed in New York by the York Theatre Company, is a fictionalized account of the struggle of Andrew Wiles to prove successfully in the end Fermat's last theorem. It followed the Pulitzer Prize-winning play Proof by David Auburn, about the death of a brilliant mathematician and the repercussions for his daughters and student. Sometimes mathematics is made more palatable and human by telling the story of those who pioneered it, or presenting it in a fictional setting. But in truth, maths is by nature a profoundly human endeavour, no less fantastic and fun in reality than the tales that have been woven around it.